This is a conversation with Afrez, who is the founder and CEO of MangDang. MangDang makes an open source robot dog named Minipupper that's roughly the size of a shoebox and runs the robot operating system. What I think is so cool about Minipupper is that it seems well positioned to lower the barrier of entry for a good robotics education. I think this is true for two reasons. Minipupper is inexpensive, yet quite capable, so you can do and learn interesting robotics things with it. And Minipupper has a community around it, both with the robot operating system for software and as an open source hardware platform with a good number of users. This community is important so that people can turn online for help rather than requiring an in-house expert. I'm Audrow Nash. This is the Sense Think Act podcast. Thank you to our founding sponsor, Open Robotics. If you enjoy this episode, please consider subscribing. And now, here's my conversation with Afrez. Hi, Afrez. Would you introduce yourself?
Hi, Andrew. Sure. I'm Afrez. I'm the founder and product manager of MangDang company. Yeah.
And what do you guys make at MangDang?
Yeah, MangDang, when you set up a company, you have to give a name. Finally, I select my hometown name. MangDang is my hometown.
Gotcha. That's a nice name. And you make the Minipupper. Would you tell me a bit about the Minipupper?
Yeah. Minipupper is a ROS, Open CV robot dog platform, mainly for education. Actually, it comes from Stanford Pupper project, another very awesome open source project. Yeah.
And what does the Minipupper look like? I think you have one there, but just for our listeners.
Yeah, this is the Minipupper. It have a LCD display.
Yep.
12
so it's a.
UF.
Oh, go ahead.
Yeah.
I can describe it if you like, from how I think it looks. It's kind of like a little Spot from Boston Dynamics, like a little quadruped robot dog. And
yeah,
it has
you know.
Oh yeah, go ahead.
Yes, you know, you maybe, I think most of the guys already see the demo of from Boston Dynamical Spot Mini, and I think most of the guys want to own their own robot dog to explore the
Definitely.
futures. But you know, you know the price is so high, and it is hard to accept it. So so we want to make a similar mini robot dog that everyone can order it, can accept it.
Yes, and then one thing that's very different between the Boston Dynamics one and Minipupper is very small. It's like, how long is the body? Maybe it's 30 centimeters or a foot long, and it stands at maybe
20?
20?
Yeah.
Okay, so 8 inches long, and it probably stands, what, 10 centimeters high? Or 15 centimeters high?
About 15. 15
About 15?
cm. Yeah.
6 inches high. So it's really cute, and then has the LCD or the display on its front, so you can have eyes and this kind of thing.
We can also add LiDAR and camera sensor to do the ROS function.
Yes, and then so how did Minipupper come out of the Stanford Pupper? Like what's the origin of Minipupper?
Okay, it's an interesting story. Beginning 2020, at first I was only a fan of Stanford Pupper project, and sometimes I will answer some normal question in the group for other guys, other new guys, and then we made a good friend with Nathan Kao, the project owner. And then as the Stanford Pepper vendor, we shipped many Stanford Pepper kits worldwide. And after such a global success with Stanford Pepper, we've got a ton of feedback from the customers. What do our customers want in their products, and what kind of products do they like? We learned a lot of cool lessons and how to make a robot. After more than 1 year, we released a Minipupper product. Yeah.
Gotcha.
Actually,
And how?
Minipupper is inspired by Stanford Pepper and in light collaboration with Nathan Tao, the original creator of Stanford Pepper.
Ah, how is it different? So Minipupper is a little smaller than the Stanford Pupper, right?
Much smaller.
Are there any other differences? So maybe the Stanford Pupper is, I don't know, it stands a foot high or something like this, or 30 centimeters high. Is it bigger than that?
Yeah, it's about more than 35. I remember 35 or 13.
35. Okay, 14 inches high, something like this. Okay.
Yeah.
So how else is the Minipupper different than the Stanford Pupper? You made it so that it could be better manufactured, or?
Yeah. Actually, as I said before, we delivered several hundreds Stanford Pepper device and got much help. And we know, actually, we find Stanford Pepper project is an awesome project, but there are also some problems. So we want to fix them. For example,
what kind of problems?
For example, about assembly, we actually optimized some point. For example, we change a servo place, to make it more easier to assemble and remove if there is something wrong. Yeah. This is the assemble. And about the calibration, in Stanford Pepper original project, we should use a command line to calibration. Yeah. In Pepper, we implement an GUI tool, and the user can use it very convenient. And the third change point is we make it smaller, much smaller, to make it more safe, security. When you debug a robot, sometimes it may be out of control. If the server performance is so powerful, it may be the security risk. So we make it, especially for the children.
Yeah, for sure.
So we make it much smaller, and it is safe even for children. And about the software change point is in Stanford Pepper project, it is based on Linux. It is good for programmer. But in Pepper we enhanced the software. We supply the Ubuntu version, ROS version, for the ROS Slam navigation and OpenCV AI functions. Yeah, people can use it to explore much more use case. And then the document, we especially for the actually when Nathan Tao released the Stanford Pepper project, I began to follow his project and buy all the components from USA and studied it as a project. At first, the source code is not stable. The document is not very well, but now it is okay. Yeah, but actually, I remember I used almost 2 months to run Stanford Pupper project. So I think if we want to release a project, we hope our user can use it very easily and very quickly. For example, 1 day, 2 day, or several hours, they can assemble it and enjoy it. So we supply more document or user guide.
Yeah. Gotcha. That's nice. I mean, if it has poor documentation and the source code is tough to go through, it can be such a bottleneck to like actually getting anything done with it or trying things on it. And then the fun robotics project can be very difficult. So this sounds really nice if you improve the documentation and give it ROS interfaces and things like this.
Yeah,
Let's
exactly.
see.
We also prepared the pre-imaged, pre-compiled image. People, if the customer don't want to compile the source code for several hours, they can download the image and flash the SD card. It can.
Yeah. So you can set it up more easily to have it all running. Wonderful.
Yes.
Let's see. So I'd like to get into, I would love to talk about the software, but I'd like to get a little bit into the hardware of the Minipupper and like what it has on board. So how first off, it has a Raspberry Pi for the computer, right?
Yeah.
Like the main controller is the Raspberry Pi. Okay.
Yes.
And then
Stanford is also based on Raspberry.
Yes, awesome. And then you probably, what do you have, like a motor driver board or something that the Raspberry Pi controls, or how does it work? And then it's connected to servos.
Actually, we customer board connect to Raspberry board.
Oh, a little Arduino.
Yeah.
Is that an Arduino? I can't quite tell with the.
We connect all the servers to our customer board.
Oh, your custom board. Okay.
Yeah, this should be easy to understand. So this is a Raspberry board.
Yep, there's your Raspberry Pi. Your custom board.
Yeah.
Just plops right in, and the custom board has a circle missing from it, and I guess that's for some peripheral or something that the Raspberry Pi that sticks through it. That's very cool.
Yeah.
So then how many servos does the Minipupper have? 12. Gotcha. Yeah. And so for each leg, what's so I assume then it's 3 per leg.
Each leg there are three servos.
You are so prepared with all the different pieces for explaining it. Love it.
Yeah.
Okay. So you have the basically the elbow of the leg, the shoulder of the leg, which moves one direction, and the shoulder also moves. Let's see. So you have 2 degrees of freedom in the shoulder.
Yeah, exactly.
Very cool. And these, so they're servo motors, and you custom built them, right, for the Minipupper?
Yes. Actually, we don't hope to customize it, but we have to, because at first we buy all kinds of mini servos from the market, but we don't find anyone can meet our requirement. You know, if we want to design a mini size robot dog, and we have to use a mini servo as smaller as possible. But when we buy the on the shelf servo, we cannot find anyone can meet our requirement. You know, we can sometimes we assemble it and run our robot several minutes or several hours, the servo will break.
Oh.
Yeah. So we at last we spent I remember about 3 months to work with our factory with our servo factory to customize the servo. Yeah.
Gotcha. And you made them, what was the major challenge in making your own one? Like why couldn't you use the existing ones? They weren't small enough, they weren't reliable enough. You said they break frequently. Is it just reliability?
Yeah. Yes. If you want to make a customer serve, if you have enough budget, it is easy. Because if you want to make a customer component, the factory will ask your forecast and your budget.
Yeah.
If you enough budget, there is no problem. But actually, we have not much budget at first, so we have to reuse as many as their components, and also can meet our requirements.
So you're saying the factory wanted to reuse its existing tooling to make the servos, or do I understand right?
Exactly.
So you can keep the price down because it's already what the factory has.
Yeah. But we co-worked with Servo factory and replaced the motor inside. We use the best motor, and we we adjust some parameters in the control board inside the servo to meet our requirement. Yeah.
Yeah, and the motors, they're servo motors, so there's no series elastic component. Do you know what I mean? There's no spring in series with the motor or anything, or is there?
No. In the servo, inside the servo, there is a very small motor. Yeah.
Yep. Is there a spring in the motor, or do you? Because you know how with some of the legged robots, they'll do series elastic actuation. They have a spring in parallel or in series with the motor, so it can deform and deal with the hard impact of the motor hitting the ground or of the feet hitting the ground.
Exactly. Yeah, exactly.
Do you do?
When we run the robot, there will be very hot inside the servo. So
Yes.
we have to we have to find the solution how to when it's so hot, how to make it work stable.
And what do you do?
Yeah.
Or you just found a good solution to that?
Yeah. Actually, the Servo factory and us do a lot of tests and also adjust some parameters about the control board inside the servo.
Okay. What kind of parameters? What do they adjust? So is it basically how hard the servo will try to maintain an accurate position, or what, like how much effort it will put into that? I'm not terribly knowledgeable about servos and controlling them.
Yeah. Actually, there are. I don't remember very clear. I think there are about 2 parameters, and one is we adjust the parameters, and another solution is they changed they replaced a much better motor inside and other mechanical optimization.
Gotcha. Yeah. To make it so you can handle the heat and make it suitable for a legged robot. Gotcha. So is Minipupper, is it basically you have the control board in the middle, and then you have a way of communicating to the servos and driving power to it. But otherwise, the legs are just the servos connected basically in order. There's no springs, there's no soft components, there's this kind of thing. And it works because it's a small little robot, right? Or
Yeah.
is that a fair way to describe it?
Yes. You mean whether it is any feedback about the position feedback, about the torque feedback,
Oh, I'm sure
right?
there's position feedback. I mean,
No.
what?
No, this version, now the third version, there are no any feedback.
Wow, it's all open loop.
Yeah, open loop. Yeah, exactly. But
Gotcha.
if we use we always balance the price and the performance. Yeah, we
Yes.
can also easily buy the serve with many feedback, but its price is
Yes.
so high.
Oh, so your servos
yeah,
don't even have feedback. Really?
yeah,
Wow.
yes. Now version
That's
there is
I
no
thought
any feedback.
servos were all closed loop, but I guess yeah, if you
Yeah. If so now Minipupper our control algorithm is open loop control.
yep.
It is simple, but it is also if you want to do some deeply algorithm, it is hard to do because if there is open loop. But in the next version, we are designing our next version. We will add
Close the loop.
the feedback. But as I said before, we have to balance the price and the performance. Yeah.
What is the
In
price
our
of Minipupper now?
yeah, about $500 for the kit.
Gotcha.
The good news is in our next version we will add the position feedback with not much high price, almost the same price. We find a simple way to get the position feedback. Yeah.
Very cool. Okay, when do you think that next version will come out? Because you just
I
had this
hope
current version, I think.
yeah. This is current version. Our next version we can release it in June or July.
Wow, so fast. Okay,
Yeah.
that's awesome. How do you get the robot to walk? Is there like an open source robot legged locomotion lab, or open open source library that you can use, or did you write it from scratch, or how do you do your legged locomotion control?
Yeah. This is another story. At first, we our software based on Stanford Pupper software. We have two version software. One is the base version. It is the similar Stanford Pupper. Yeah.
Okay.
And the other version is the Rose version. In the Rose version, we have to implement the framework to control the lag. It is a very common framework for the wheel robot. There is a Turtlebot platform used by many guys. Yeah, it is a very common framework for the wheeled project. But if we want to implement the legged robot based on those platform, we have to design and implement the framework. At first, I asked several technical guys and discussed I remember almost 2 months how to design it, how to implement, how long can we implement the
Will it
framework.
take?
But
Yeah.
at last, we are very lucky. We found there are already a good project in GitHub, another open source project that named Pupper, led by Juan, who is located in Singapore. We are very good friends now, and during our project, he also give us much help. Yeah.
Wonderful. So you found an open source solution you were able to use with ROS. And that gets you most of the way. Did you have to extend it, or did you put code back into the original to improve it, or did you just use it as is?
Actually, it is not only just integrated. We are based his project, but we are also double confirm with Juan, discuss with Juan, and how to use it much better on Minipupper.
Yeah, you optimize it from there, so it works really well.
Yeah.
Awesome.
Exactly.
Okay, how did you optimize it for Minipupper? Like I've seen some things where they would have the robot soccer tournaments, and they'd have a little Now robot go and try to kick the ball. They were trying to make the Now robots really fast. I think it was Now. Actually, I may be wrong. I think it's not a Now robot. I think it's some other humanoid robot. But what they did is they would set them up and have them race back and forth with different parameter sets to try to find the fastest parameters. How did you get it prepared for Minipupper? Did you do something similar where you're racing them back and forth, or how did you find what works really well?
Yeah, our target, Minipupper target is for the education, but not for the race competition. So we have to make it as simple as possible to make other guys to study or customize. If the robot, because it is a very small robot dog, and the component, the serve is a low cost serve. Its performance is okay for Minipupper, but it is if you want to run very quickly, maybe it will not stable. Maybe
fall over.
Yeah. But if it run up and down, you cannot use the lidar. It is difficult for lidar to do those slam and navigation, because if it is not stable and up and down,
it's shifting. Yeah, it keeps breaking its map.
It is difficult to build the map.
Yes, because you use the planar lidar, right, on Minipupper. So it's the lidar that shoots straight out. And so if you have the plane going out and it's tipping, and you're trying to use that as your map, that would be really difficult, I imagine, to build a world map.
Well, exactly. We must make it run more stable. And then user can build their map.
So stability was kind of the big thing you optimized for when trying to make Minipupper walk, not like speed or anything, because you're interested in it for education, and that means like, can you learn with this as a platform? And so then you can try learning about lidar and whatever other sensors, your cameras. Okay. Tell me a bit more. So is this robot already being used in education? And where and how is it being used in the curriculum?
You mean the education, right?
Yes.
During we deliver the Stanford Pupper units, we found many. Some of the users come from the university. Most of the university, even some PhD students.
Yeah.
and they hope for they can they looking forward acceptable robot dog platform to test
Hmm.
their algorithm, maybe as a video algorithm or other AI algorithm. So
Mm.
we discussed with them, and now, as I know, some universities are trying uh, to use Minipupper for their lessons, and we
Hmm.
are also discussing with them uh, how to improve Minipupper and what they
Mm.
are looking for. Yeah, I think it is
Mm.
a long journey to improve the education platform.
Yeah. So it's mostly targeting universities, not like high schools or middle schools or anything like this.
Yeah, actually, it can
For
cover
now.
all levels. Now,
Yep.
the most students come from the university, but there are also some come from the middle school, high school, but
Wow.
not much.
Okay.
If we,
Yes, just
if
starting.
we, yeah, yeah, because
Gotcha.
robot project
With
seems not easy. Yeah,
yes, for sure. Especially, I imagine going from university, like starting with grad students and then going towards maybe undergrads and you teach them during their education. And then like the further, the lower in age you go or the lower in education level, I imagine the harder it is because you need to develop a more structured curriculum, I would imagine.
yeah, yes,
Like with the PhD students, you say, here's some documentation on how it works. They go off and do things.
yeah.
And then with the undergrads doing their coursework, I imagine you still have to put together a little bit of a curriculum or work with professors or technicians at the university to put together a curriculum. Have you done much of that where you're putting together a curriculum around Minipupper and the kinds of things it can do?
Yeah. Uh, Now we are just supply Minipupper as their base platform.
Mm.
The university students have the technical background, and
Hmm.
we only can supply the general user guide, and if
Yep,
they can build it, and if they have some problem, they can send us a
they
mail.
come to you.
Yes, we can support them. But yeah,
Gotcha. Any plans in the future to possibly help with the curriculum design around the Minipupper? Or is it kind of your documentation is, in a sense, well, it is the documentation you're planning on using, or not necessarily attaching a course to it?
yeah. Actually, we are planning how to make a detailed document or user guide.
Ah,
We hope to make it a real education platform, not only for the universities. As you said, we can also hope also help the middle school, high school students to
yep.
learn and study. Yeah,
Hmm.
we can make a detailed document for all level users.
Ah, gotcha. Have you started that, or is it it's a future effort,
Yeah, we
or where
already
are you
started.
in that?
Yeah, we have online document,
Hmm.
and we will add uh, add the additional part step by step. Yeah, we hope we can finish the document uh, within 3 or 5 months.
Ah, very exciting. And then maybe you'll see more universities using it and it will grow from there. Yeah, it'd be very cool to have a
Yeah,
very nice,
yeah,
inexpensive,
yeah.
legged robot. Like, how cool. I mean, in my robotics education, I was lucky to have the thing, but like little tiny robots that had a LiDAR on top and did navigation. And legged robots are just so much. I'm so much more interested in legged robots than wheeled robots, and so it's really cool if that can be in the education program.
Yeah, yeah.
Huh. How do you work to make really good documentation? Because I think a lot of, like, many of the robots I've used that have come from factories have had pretty terrible documentation. How do you try to make good documentation? Any ideas on what you can do to make it as good as possible? Or
yeah, at first we have many improvement of the document. At first we made our first version document, and user will give you many feedback, and the user maybe make their own user guide. For example, we released we released many hundreds of devices to Japan market, and some Japan makers make their own document, very detailed document. So I have confirmed with them.
Put it back in.
Yeah. So we actually, the document is not only come from us, but also come from all the guys, all the customers. We are co-work together and contributed to the document together and make it more and more better.
Gotcha. Very cool. And so you mentioned a little bit, you can put a LiDAR on top of the Minipupper. I think you can also put what is it? Is it an OAK-D 3D camera?
OpenCV 3D camera module. Yeah.
Yep.
So it is led by Brandon team. Brandon is the OpenCV key architect, and he is also the CEO of Luxonics company located in Seoul, USA. Yeah.
Gotcha. So you put these sensors on, and these are so that people who are interested in playing around with it, so whether it be students, or I could even see hobbyists being very interested in playing with MangDang. Like I, for example, am interested in playing with one of the Minipuppers. But so you can put these sensors on it, and with the camera and the LiDAR, you can build a map, and you can do a lot of different robotics things, because you can have the robot map its space and move around in the space and do some understanding of the scene or the environment. That's kind of the intention with those, to enable it so people can use them, or I don't know. It's quite cool.
You're right. Yeah, you're right. We put the LiDAR at this place, and we can put the camera at this place. Yeah.
So the LiDAR kind of sits on the back, and the camera sits a bit further forward, kind of on top of the body.
Yeah. We also supply the user guide for the LiDAR and the 3D camera module. User can, but our guide now is only the basic guide, and user can use our guide to run the sensor. But if user want to implement some use case, they have to study and implement their use case
themselves. Gotcha. And so this is, and it's running the robot operating system, or ROS. Is it running ROS 1 or ROS 2?
ROS 1.
ROS 1? How did you, so, let's see, how did you decide to, well, for ROS 1, was the Stanford Pupper running, wait, was the Stanford Pupper running ROS 1, or you brought over ROS 1 for this and implemented, or found that one package that worked really well for the legged locomotion?
We built the ROS environment. Stanford Pupper only support Linux OS.
Okay, so this was, you were saying you found that one repository online that did a lot of the legged locomotion for you, the control of the legs for walking, and that was ROS 1? and then
Yeah.
you've kind of, gotcha. Do you have any plans on moving to ROS 2? Or is ROS 1 the good one for now?
ROS 1 is work very well now, but we are also discussing several times how to update to ROS 2 version. And we hope, I think it needs a lot of work to update it.
Yeah,
But I think we have still a not very clear plan to update to ROS 2. But we also hope to update it. Maybe
gotcha,
I hope we can update to ROS 2 before the end of this year. Yeah, we can
gotcha.
update in this version robot and our next robot.
Hmm. Yeah, it seems like a lot of companies are kind of feeling this pain of transitioning from ROS 1 to ROS 2.
Yeah, exactly.
There is something, if you use the Python client library for ROS 1, there's a thing that, I forget, it's underscore ROS Pi, and you can import it and it just uses ROS 2, but it keeps all the same ROS 1 interfaces. I thought that was quite cool.
Okay.
I don't know if that would ease the transition, but I don't think there's a C++, I don't think there's a C++ client library analog to that at the moment, but it's a cool idea to just switch it out so you can use it and then you can gradually replace things as you go from there.
We can. We are trying our best to move forward step by step, but yeah.
Gotcha. Let's see. So when a user orders one of these mini puppers, it's a kit and they have to assemble it themselves. Is that correct?
Yeah. We supply several SKUs. One is the basic kit. Uh, you know, some makers they already have their recipe board. They don't want to buy additional board, so they only want some component. So we supply the basic kit and not include the recipe. And some guys said, I hope to buy all the components and I can assemble it easily. Yeah, some guys said, I hope buy the pre-assembled units, and after I get it, I can enjoy it right now. So we actually we supply 3 SKUs.
Gotcha. That's cool. And the body of it is 3D printed, right? And the legs as well, or several of the components are 3D printed, right?
Yes, this is one of the challenges for our product. Yeah, we are 3D printed it. If you if you only make a prototype, 3D printed is no problem. You can print it with several hours or many hours.
Yeah.
But if you want to mass production, for example, when I travel to Shenzhen, our vendor, I ask them, I need several thousands of units for 3D printed. It is hard to find the the vendor because it is time consuming. Yeah.
So let's see. And the trade-off is that you can 3D print, and it's really good for prototypes when you're doing like one here and one there and learning.
Yeah.
But mass production, if you were going to make 100,000 of them, then you go and you get the molds done so you can like cast the parts or something, and it's very efficient, but it's very expensive up front, right?
Exactly,
but so,
exactly.
and Minipupper is kind of in the middle where your volume is not incredibly large. It's not like hundreds of thousands. It's like thousands, perhaps. And so that's
Talking
why
about,
you're thinking 3D print?
yes, for some part, you see for some yellow part, they actually at first all the components are 3D printed, and then it is hard for us to find the vendor who can
Yep,
supply so many 3D printed
3D
kits.
printed parts.
So some of the part we actually now is mold from mold, and some parts
Ah,
are 3D printed. Balance
I
the
see
yeah
the cost in the end of the
the
day.
cost. And,
Gotcha. And so maybe for the next model that you think will come out, you said like June or July or something, I think. That
yeah.
one, are you moving more and more towards molds for everything? Like try to reuse as many of the pieces as you are already having molds for, and then eventually have it be more
Yeah, so
molded?
we will reuse some of the mold parts.
Hmm.
Yeah, yes. We actually maybe our next version is you see we can remove this part, rest pad,
Okay.
remove this part. Oh, yeah, then we can have a very good platform. You can add
So if you remove kind of the bump in the front, then you can have a big
yeah,
flat space to put sensors and whatever it
yeah,
is you want.
exactly.
Yeah.
Yeah, exactly.
Awesome. Let's see. So we're touching on it a little bit. Would you tell me a bit about the manufacturing process of this? And so you were saying before we started recording, you go down to Shenzhen and they work on, like, it's easy to prototype, and just tell me a little bit about the manufacturing down there.
Oh, that's yeah. Yeah. First, it is not easy for the hardware hardware device, especially now for the now
Hmm.
situation. You have to uh, powerful supply chain capabilities. Otherwise,
Hmm.
you can't got your component. But the good thing is actually I have several years of the hardware products, and I also have some resource, supply chain resource, so we can
Mm.
get our component. Yeah, yeah. We also we use the Raspberry board, and it is also very hard to get the board
I've heard, yeah.
now. Yeah, yeah. But we are so lucky, and we I'm wondering, thinking how after our campaign and we have to prepare the production. The most
Hmm.
important commodity is Raspberry. Before
That's it, yeah.
we starting Minipupper, we can buy Raspberry easily at
Yes.
acceptable price. But after end of our campaign, it is hard to get Raspberry. But we are so lucky,
Yes.
and even Raspberry CEO liked our product on our
Wonderful.
Twitter. Yeah, yeah, yeah. We are so lucky, and so I connected him and sent a message to him. I say,
Ah.
we need a Raspberry bar for our product,
Hmm.
and so actually we got enough Raspberry board from Raspberry company in
Uh-huh.
UK. Yeah, we are so lucky.
Oh. That's so funny. Yeah, the part shortages have been really tough, especially for hardware companies, and especially like, I don't know, I hear stories about companies ripping out Raspberry Pis from other devices so that they can use them. So like buy a $200 thing, then rip out the Raspberry Pi, which was like $40 before this
Yeah,
whole
yeah, yeah,
supply shortage.
yeah,
Gotcha. So it's really nice that you have the ability to keep getting Raspberry Pis. Let's see. And so,
And the lead time during the manufacture, the leading time is another risk, because of
the leading
you
time,
know
so the parts, you
yeah
mean, or what does the leading time mean?
one of the stories at first we hope to release all the device, all the key to our
Hmm.
backers before the end of
Mm.
last year.
Yes.
But during I push our fact I also located in our factory last year and push their
Uh-huh.
progress. But
Ah.
last year Shenzhen, the COVID-19 situation is not very good, and
Mm.
we have to delay the shipment. So
Yep.
it is very hard to control the accurate deadline for the shipment.
For the whole world. Yeah.
Yeah,
Especially, I mean, it touches so many places and so many industries. The Raspberry Pis, I don't know where they're made, but you said it's a UK company. And then you have the Shenzhen area, and then there's the whole global pandemic situation. There's parts and materials that need to come together. So
yeah,
yeah, I could imagine that it would be very difficult to predict the lead time
yeah.
for all the parts.
Yeah, yeah. During the manufacture, I really hope for many thanks for many guys for give our much help. Raspberry,
Mhm.
even Mac, through his team, give us much
Yeah.
help and other friends.
What's the process when you go down to Shenzhen and you have an idea that you want to get made? How does it work? You go to different companies and or different factories, and you say, "I want to make this," and then they work out what they can do, or how does it work? How does it work to manufacture something in
Yeah,
Shenzhen?
actually, it is not a lot of hard work and dirty work, because if
Yeah.
you want to, for example, our server, customer serve. At first,
Yep.
the server can work, but it cannot work fast. So I just leave a hotel very near the server factory. Every day, I
Ah.
went to their factory and work there and push them day and day.
Oh wow,
Yeah,
that's crazy. Yeah.
yeah. I said that we have to find the best solution for the best performance. At first, they said,
Yes.
no, no, it's impossible. But if you push them day and day, finally we found the solution. Yeah,
Wow. Yeah, I've heard that a number of times where like the CEO or COO or whoever is responsible for manufacturing will go and just basically stay with the factory and keep pushing them to try to make refinements and improve the quality or get it to work in some way, this kind of thing.
yeah. We are we are a very small startup company, and before the campaign, there is I was the only guy, the full time for the project.
Wow.
Other guys are part
Okay.
time, and
How large are you now?
yeah. Now we have several full time guys. Yeah,
Gotcha.
but
Several
not
like
much.
five or several?
About five full time, and
Ah,
several other part time guys.
gotcha.
Totally about 10 guys.
Yeah, about 10 guys with full and part-time. I see.
Full
Okay.
time
And
is
then
only five guys.
gotcha. Okay. Yeah, you were the only full-time when before the campaign. And so the campaign, that's a Kickstarter campaign you're referring to, right?
Yeah. Yes, about the campaign is a lot of funny, interesting story. And
Oh, I'd
at
love to
first,
hear.
let me share you the story. It's a long story. But
All right.
yeah, at, at, yeah, at first, back to 2020, we are the Stanford Pupper vendor and co-work with Nathan Cow. And after we released the Minipupper, Nathan Cow also put Minipupper onto on their Stanford Pupper website. And I think maybe we can sell or deliver Minipupper just like Stanford Pupper. They put the information on their website. If the customer wants to
give it good visibility.
They can send a mail and pay by PayPal or other online payment. Because I have no any crowdfunding campaign knowledge before Minipupper. But someday Nathan Cow said, why not try campaign? I said, I have no any background of a campaign. Maybe it's impossible or difficult for me. So some days later, they send me the same message again and again. Why not try campaign? Someday I have the free time and Google what's the meaning of a campaign, and I started to study how to make a campaign. So I'm not very clear. It's hard for me to make it clear. Anyway, I made a decision to do a campaign. I thought whatever the result, it should be very interesting, another interesting journey for me. So I decided to do the campaign. If you decide to do campaign, you have to prepare all kinds of lessons and prepare all kinds of work. And I also double confirm with some vendors or some friends, ask them how to do the campaign. But some questions you can get the answer easily about the campaign process. But some question is not easy to find the answer, because if you want to do the campaign, you have to prepare the PR video, some of the pictures and the campaign page design and all kinds of work. So at first we discussed with several vendors how to do the PR video. If you have enough budget, you can do it easily. And there are lots of professional. There are lots of professional team connect you and say they can do the PR video. But the budget is, for example, $20,000. But now, but at that time, it is difficult for me to decide, because
it's a big investment. To decide. Yeah, especially if it's just you, for sure.
Actually, at last, I asked my friend's friend team to take to record a video. But the interesting is before 1 week before the campaign, the guy who helped us make the PR video hurt his hand, and he cannot edit the video.
Oh, no way!
And we haven't prepared the voice, because we have to prepare the video and the voice. At last, at last, I finished the last step, find the voice and integrate the combine the video and the audio.
Gotcha.
So at last, although the final PR video is not so professional, but it can work.
It's quite
another,
nice.
Yeah. Another very interesting is if you want to make a successful Kickstarter campaign, you have to got the Kickstarter campaign official platform Project We Love label.
Yeah.
But I have no any other no any know-how about the campaign. The question for me is how to get the Project We Love label. I asked another guy help me to do the campaign. At first, even before the 1 week before the campaign, I asked him when we can get the Project We Love label. And he said, if your project is good enough, you will get it.
Yeah.
but this is not the answer I want to get. So I asked him time and over time again. And it is hard to get the exact answer. But I don't like waiting, just waiting the label. So I try to find the Kickstarter campaign contact window, and I want to double confirm with the official contact window. So at last, finally, I found the contact window header. She is the header of the design and tech category of Kickstarter. And in the I sent her a mail, introduce our Minipupper project, and hope to book a video conference. I remember it's one Thursday afternoon. So before the surprise happens, our video meeting is before the video meeting, I think we already made a campaign page that is very rough, very draft version. The video is not the fixed version. Some pictures are not the fixed version. Looks not good, and
not very professional. Yeah.
The page looks actually looks bad.
Okay.
But before the meeting with Heather, we send the page link to her and introduce our more information of Minipupper. Our video is Thursday afternoon, and we are surprised. And at that Thursday morning, we find our project already Heather already gave our project We Love the label. Very interesting, very surprised.
Yeah. I bet that was so nice. Very happy, I would imagine.
Yeah, very happy. And after we get the label, I asked the guy who helped, who support me to do the campaign. We already finished our target before the campaign. What's our next target? So interesting.
That's crazy. Yeah, it was a very successful campaign. Congratulations. Hell yeah.
Yeah, thank you. Another interesting is we OpenCV at that time we branding team also did their Kickstarter campaign at that time. We almost do the campaign at the same time. The interesting is Brandon is Cat Scott is also your
at Open Robotics.
Yeah, she introduced the Brandon to me. She linked us together, and
wonderful.
We are very close. Yeah, wonderful. Well, we are to work together more and more deeply. Branding team now have already built their robot hub.
Hmm.
Their hub will use our Minipupper, and we
Awesome.
will work together. Yeah, more and more deeply. Yeah.
That'll be great. What do you think? So you'll work together. Um, I guess where do you see Minipupper going? So you already mentioned that there's another version coming out, and you're putting together the documentation. Where do you kind of see it going? Maybe 2 to 5 years from now.
Yeah, in my dream, we hope we have two product line. One is education. We
Hmm.
really hope to release good, a good robot dog platform for education. That everyone, not only university students, but also the middle school, high school students, and other any uh, guys who like the robot dog, they can study and enjoy the
Hmm.
robot dog product. And another product line is the home robot. We hope,
Yeah.
we hope we can release a useful and valuable and acceptable home robot. Home
Hmm.
robot with a leg. Home robot dog. Consumer
Mm.
consumer robot dog. But
Ah.
it is not easy because
Mm-mm.
we have to move forward carefully, step by step.
What do you mean? Why? What are some of the obstacles that you must figure out to move forward for the consumer robot dog?
Yeah, for the consumer robot dog, we have to make it the product as simple as possible.
Hmm.
If you have some technical background, we can discuss how to calibration. Yeah,
Yep.
but if for the consumer product, you don't you cannot see or you cannot teach the customers to calibrate. It is not
Yeah, that'd be nuts.
it is impossible. So
It has
we
to have
have
like
to make
one
it.
button, like a Roomba, and then turn on and do things, and also has to
Yeah,
be cheap too.
yeah.
Like,
The price should be very cheap, and the function should be very stable. Yeah.
yes.
We hope we are trying our best. Maybe uh, before the end of this year, maybe we can release our consumer robot dog prototype. Maybe
Ah.
later this year or early next year.
What do
We
you
have to
think?
study.
Oh, go ahead.
Yeah,
You have to
we have
study
to
what?
study. Yeah, study uh, the 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 real requirement from the customers. During Stanford Pupper, we released about 500 device, and
Yep.
Minipupper we already released about 2K,
Wow.
2,000
That's wonderful.
device. Yeah. And our next version, I named the Minipupper V2. Uh,
Hmm.
we hope to release it in June or July, and I hope we can release it 5,000 or 10,000 device. If you
Mm.
release the more device you released, the more feedback you can get. Yeah. If you
Hmm.
got the more feedback, you can make it better and better.
Definitely.
And someday you can find the consumer solution.
Yes. It seems like the Mini Pupper and Mini Pupper V2, it's a smart way to, one, get feedback, as you're saying, and two, grow the number of units that you're making, because the consumer one will probably be fairly similar, and you can refine the control algorithms and you can refine everything else about it. So it's a nice way to go from a small market that lets you keep growing to a much bigger market to grow a lot more, I think. Sounds like a good plan
Yeah,
to me.
exactly true. Yeah. Because
Gotcha. Very cool.
actually because we have not much budget to try. We have to move every step very carefully.
Yep. I see. Yes, it's very much taking what you have, getting a little more, reinvesting it back into your company, grow a little bit bigger, and do the same thing, grow, 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 until eventually you can be a big company. Ah, I hope to look back in the future and see you guys be enormous, and very successful company.
Yeah.
So with the consumer robot dog that you're imagining, what will it do? So is it just going to walk around? Is there the human interaction part seems really difficult for that. But what's going to be kind of the thing that people buy it for?
Got your point. I was asked by many guys the same question. Yeah.
Yes.
In my opinion, it is. I think no one can give a very clear answer. For example, if the answer is very clear, I think.
Everyone else has already done it.
I think if the market is very clear and the product feature is very clear, and we have no opportunity for the startup company. The big company will do it. Yeah, but for me, I believe you can imagine after 3 or 5 years later, I think the home robot market will come. I believe that. But what kind of a home robot looks like? I believe it should be the leg robot, but not the wheel robot. So if it is the leg robot, we can imagine it is a 4-leg or 2-leg. For now, maybe the finally, I think is the 4-leg because it is more like animals.
Yes.
So I believe the imagine. So we move that target step by step. But at the first, maybe at the end of this year or early next year, our first home robot prototype, maybe you can think it is a mobile smart speaker, a mobile camera.
Yep. Kind of like Amazon is doing and a lot of these other home robot companies. Gotcha. Yeah, and legs, I mean, like carpet is not a problem if you have to like step up onto the carpet or stairs or anything. Like if you have a legged robot, there's a lot of advantages for getting around the home. Especially if it's a consumer product. Like you buy a Roomba and it can't go in the like little dip in the living room or something like this that has a stair to it or whatever it might be. So legs clearly have those advantages. 4 versus 2 is an interesting discussion. 4 is a lot easier, I think, as a roboticist because you can be passively stable at any time because you can have 3 points of contact or this kind of thing. Very interesting.
But you think maybe 5 or 10 years later, if there is a home robot with 4 legs, you maybe feel very good. It is like an animal. But if you find that there are 2 legs, like a human in your home, maybe it is not feel better.
It's like a little human. Yeah, it's a little stressful. I could see that. I wonder. I mean, birds have 2 legs also. So like chickens and things like this. And we're not terribly intimidated by them, but I think a chicken-shaped robot would be very funny. Like that's not a design that I see, I think, ever. But yeah, I see what you mean. And then also easier to manufacture probably. Point like feet are really hard as far as I understand for like
Yeah, exactly.
bipedal robots
Yeah, exactly.
because like Mhm.
Yeah.
but a lot easier with
The
like
most
4 point feet like you're doing with Minipupper.
yeah, the most time consuming part is the leg part. In our next
Yeah.
version, we have two. Now version, I still need about 3 hours to assemble it, and
Oh.
additional half an hour to calibration it. And in our
Ah.
next version, of my target is customers. I need more than 3 hours to assemble it.
And you've done a lot of these,
Other
yeah.
But other customers maybe need much more time to assemble and enjoy it. In our
Yep.
next version, I hope the assemble we can assemble it within 1 hour and don't
Mm.
need do any more calibration. Maybe
Yeah,
the auto calibration.
that would be nice. Yeah.
Yeah.
Let's see. Um, Bigger picture, I'd love to. So, segueing a little bit, I would love to
Okay.
hear your, because I mean, I'm in the United States. I would love to hear your impression of kind of the robotics industry in China, and the manufacturing is very interesting. So, like, I don't know, how do you think of it?
You mean the robot manufacturer?
Yes, in the Shenzhen area and then around China. Just
Yeah.
I don't know how
I
like
think
for the whole robotics field, how can we think of Shenzhen and um, I don't know.
yeah. I think Shenzhen, the supply chain is wonderful in Shenzhen, and you can find all kinds of vendors, and they
Hmm.
can give you some solution. But uh, but if you want to do some innovation, uh, you have to design it by yourself. You can find
Mm.
all kinds of solutions. The common solution. It is easy to find the common solution in Shenzhen market and vendors.
Hmm.
But if you want to make some innovation product, you have to design it by yourself. Yeah,
Gotcha.
I
And so
think
if you
for
do
normal.
design it, oh, go ahead. For
I mean,
normal.
if you if you manufacture common hardware device, it is very easy in Shenzhen because the supply
Hmm.
chain is very convenient. Yeah.
Hmm. Gotcha. So if you say you do come up with something new, like you with your servo motors that are a little different than what's been done, or maybe, I don't know, anything else that's new, how does it work to get a factory in Shenzhen making it? Like, do you have to work with them a lot? Do you kind of give them what you need and they'll figure it out? Or how does it work?
Yeah. Uh, yes. About the serve, you can also find uh, many vendors in Shenzhen market, and
Yep.
during deliver Stanford Pupper, I already know some serve vendors, and
Hmm.
so we ask them one by one and compare their service and the technology
Ah.
background and select the better one, and then to
Hmm.
discuss to give them our detailed requirement and discuss our solution, discuss the solutions. Maybe the forecast now the forecast is not much, and you need it is not very easy to push them to do some customize.
Ah. Yep. Gotcha. Unless you're making, I don't know, a million of them or some crazy number. that it's really worth it for them to customize this kind of thing?
Yes, yes. Yeah, in our next version, we will redesign the serve because if you want to do some innovation or some big change to make it simple, you have to redesign some key component.
Yep. Gotcha.
Okay.
How is the I mean, this is kind of two questions. How are you guys funded, and how is the investor climate in China to you?
Okay. The first question is how to get the fund, right?
For you, so are you bootstrapping? Are you putting your own money in, and are you accepting investment from people?
Yeah.
From are you locally funded? Does the government help with your funding? Or I'm just wondering how the funding so far for you guys.
At first, let's back to Stanford Stanford Pupper project. At first, I used my own money to buy all the components of Stanford Pupper and enjoy it. And at last, I become the vendor of the Stanford Pupper and deliver because after we several discuss with Nathan Kao by email or video conference, Nathan asked me whether it is possible to supply the kit from China market because China supply chain is convenient and the price is lower. So I look around and all the components from the China market and deliver Stanford Pupper with low price. But frankly speaking, there is some profit after deliver several hundreds of Stanford Pupper project. We got some profit, and I use the profit to develop a Minipupper.
Oh.
So yeah. So when Minipupper campaign, after the campaign, we got much more funding, and then we use the money to develop our next version.
Oh.
So round and round.
Yep.
Actually, now we now it is a I didn't actually I did not use much my own money
in the latest Minipupper.
Yeah.
Nice. That's great. Let's see. And then do you think going forward, will you take investor money or try to bootstrap the whole time and keep becoming?
Yes. We have the plan to get investment maybe later this year. And we are so lucky, and we actually now we already got the incubator program approved in Hong Kong.
Congrats!
And, they will they will give us some support, not only the office, some funding, but also in Hong Kong the VC environment is very convenient.
Gotcha.
I hope we can. I hope we can get our first round invest later this year, and then we can use the fund to book more technical guys and accelerate our R&D and marketing.
Gotcha. Yeah. Let's see. So beginning to wrap up, what do you think? What do you think robotics will look like going forward? So the next like 2 to 5 years, where do you think we'll be in robotics?
Yeah, I'm very positive to the robotics market. And now the vision technology, the voice, the make real voice technology. There are many solutions, and I think they are already ready. The only need the only thing we need to do is how to combine all kinds of the functions or technologies into a product, robot product, and release it to the customer with acceptable price and the valuable usage. I think I'm very positive. I think maybe within 5 years, 3 or 5 years later, I think most of people will see more and more robot products. And I also believe within 3 years, we can release the home robot dog consumer product.
That'd be so
Maybe
cool.
not us, but some company will release it.
Okay. Well, hope it's you guys. Fingers crossed for it.
Yeah.
Let's see. So wrapping up, is there any links or contact info or anything you'd like to share with our watchers and listeners?
Yeah. All the document and resource of Minipupper is you can find it on our GitHub link. I think you can get
I'll include it.
all the things on our GitHub link.
Awesome. All right. Very good. Thank you. It was nice speaking with you.
Yeah, thank you so much. Yeah, thank you so much for this meeting.
Bye, everyone.
Okay. Bye.
Thanks for listening to this conversation with Afrez. Thank you again to our founding sponsor, Open Robotics. If you enjoyed this interview, please consider subscribing. See you next time.